Hi students, this is your Maisa. So today I am here to explain images formed by concave lens. So in previous video, I told you about the images formed by convex lens. So in today class, we are going to see how images can be formed through concave lens. So here we have two cases. So in case one, we place object at infinity. In case two, anywhere, okay, anywhere from the optic center of a lens and infinity. Okay, so these are the two cases which we are going to see now. So first case, that is when object lies at infinity. So let's place object at infinity. Object at infinity. Right. So this is what a biconcave lens. Biconcave lens, and the straight line which is passing through optic center is called principal axis. So it has four key, F1, 2F1, F2, 2F2. Okay. So as I told you, object is placed at infinity. So let's see where image is going to be captured or where image can be formed. So here we have two rays that are being parallel to the principal axis, and the two rays are coming from the object which is located at infinity. Okay. So here after refraction, the rays can passes in this way. Okay. So if you extend the two refractor rays, actually the two original refractor rays cannot meet. Yes, why? Because these two are traveling in different directions, so that there's no chance to meet. So then what we can do? So what we can do is just let us extend the two refractor rays, so that a ray a ray which is parallel to the principal axis that appears to be coming from focus, that is appears to be coming from focus after the refraction through concave lens, here we can see that. Okay, so the point where the two refractor rays, extended refractor rays can meet, so that is what the position of a image, so here the point where the two imaginary rays are meeting, so the point is called a focus. Okay, then that gives us position of a image. So let us write the characteristics of image. So here position of the image is at a focus, or f1, right? And coming to the nature, so nature is virtual image. Okay, so the image is formed due to the imaginary rays. These are not original rays. Okay, so that the image is virtual and erect, okay, or upright. And coming to the size is highly diminished highly diminished. Okay, so this is what we can see in first case. When object is placed at infinity, okay, the image can be formed at a focus. Right? And now move on to the case 2. So in case 2, we place the object AB at anywhere from the optic center of lens and infinity. Okay, let's have a look here. So biconcave lens, optic center, here we can see focus f1, and this is 2f1, this is f2, 2f2. Okay, so suppose I'm placing object behind the 2f1. For example, if we place object that is behind the 2f1, then where will be the image can be seen? So let's have a look here. AB is an object, so that is placed behind the 2f1. So after refraction, the ray is going to diverge. So if you extend it, that can pass us through focus. Okay, that can pass us through focus. That appears to be coming through focus, right? And the second ray, that is passing through optic center. Okay, a ray which is passing through optic center, that goes in straight, that goes straight without any deviation. Then if you try to look at the image, if you try to look at the image of a object, so here it is. So the point where two rays are meeting, so that is the position of a image, right? So coming to the nature, first of all, let us write the position of the image. So position is f1 in the optic center, and coming to the characteristics, it is virtual and erect, and the third, size. Coming to the size, it is diminished. Okay, diminished. So no matter where object is placed in front of concave lens, that forms virtual, erect, and diminished images. Okay, so that is what you need to remember. So when object is placed behind the 2f1, so the image is going to be, our image can be seen seen in between f1 and the optic center, so you can see the size of the image. So the size is smaller than the object, okay, that is what diminished. And virtual, erect, so image is formed above the principal axis, which indicates that it is erect. Okay, and next is location. So location of the image, f1 and o, f1 and o, optic center. So that is what we can understand. Hope you guys understood clearly. So to get more videos, do subscribe and share to your friends. Thank you everyone.